There you go. Then restart it.
Okay.
Can he start?
Okay.
No?
Does he have any sound on it?
There's sound, but it's
doesn't
okay.
matter.
It's just 30
Doesn't
seconds.
matter.
No, that's fine.
Okay, I'll explain first what's happening here. So the idea was we wanted to make a P2 run video games. We have a friend, Jim Bagley, who is an old retro gaming guy who knows about all the old consoles that were from the 70s and early 80s. And if you remember, I have some pictures of like the Space Invaders game, right? I was in 6th grade and I saw that at the skating rink and as kids are playing it, and boom, 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 kind of had a heartbeat sound and the things race and come down, you got to shoot them. Well, that thing ran on an 8080. I think that the motherboard for that thing at the time was probably this big. And it had, I think the whole system had like, I want to say like 12K of RAM. It used 1 bit per pixel and it wasn't that high res. But anyway, our objective was to like, can we do it on the Propeller? And then how many can we do? And so what we figured out was that in a video game console, let me pull up a picture here if I can, let's see, get out of this full screen mode and let's see, am I in the right place? Okay, here we are. No. Okay. Uh-oh, I got to get even this thing out of the way. Let's see. Oh, here we go. Okay. Now, if I click on it, it should open, right? Okay, here we go. Yeah, you know, as soon as you really need it to work, it's almost certain not to. Anyway, if we can see this little game cabinet, let's get the little. So this at the time was like a stand-up video game, right? You put quarters into it and it plays. And there's basically 3 things that happen. There's video, which is an NTSC baseband signal. There's audio, which is just another, you know, 1 wire analog signal. And then that thing had like 5 buttons on it. And we wanted to like see if we could make each cog emulate a full cabinet like that. And we figured we could get it down to just 3 wires, right? The audio and video are pretty easy because those are analog signals that we can generate with the P2, even the P1. Well, with the P2, we can do it on 1 pin because we have 8-bit DACs. But then the button thing was a little more ambiguous. Like, we don't want to have 5 pins for buttons. So we came up with this way to do, and let's see, maybe I can make this thing work. We came up with a way to make 1 pin be able to see 5 buttons simultaneously. You know, even though they're in asynchronous states, like any combo. And so here's what we did. And I made a little debug thing. Save changes. Did I change it? Hold on. I see what I did. Okay, now I'll run the debug. Yes. Okay, we're in luck. Look, it's actually running. Okay, so here's the circuit. We have ground, and then we finally pull up. So we have this like ladder of resistors. There's kind of a chain. And when you press a button, it shorts out that resistor. And because they're like, you know, 1x, 2x, 4x, 8x, 16, you have a good chance of resolving them. So they become this nonlinear pattern, right? But if you're never going to get this far, I think. Well, no, maybe, no, you can get down to 0 millivolts if you short everything, because that's what finally goes to the propeller, right? Is that P34 in this case. So it becomes a question of, are you in this range or this range or this range? And there's 32 of those, right? So that becomes 5 bits, which resolves, you know, which buttons are being pressed. So on these little daughter boards that we made, this was a prototype. So in the end, we have a game cabinet which has a monitor, and it has 5 buttons, and it has a little audio amp. And anyway, this is the buttons was the biggest part that was unknown. So see if I press, oh wait, did I lose my, let's see if we can get back. there we go. So if I press one button here, wait a minute, I'm on the right one, I'm plugged in. Is it?
On the scale. It's delayed.
Okay, gosh, why is it so, it's like super, you know what? This is an old Surface Pro. Let me just restart it. Restart the debug because, oh, and maybe I need to even put like a delay in there. I think what's happening is it's getting the debug update so quickly. Okay, I'm gonna add a quick delay in here. Then we won't have this other delay. Let's see. Where do I draw this thing? I made some things that are some methods that are just debug statements just for the purpose of drawing that graphic. So I should have a big repeat loop somewhere right here. Okay, I'll just do this. Down. I use the XByte thing that we designed for the interpreter. So here's like in the lookup table, these are the codes. You see all these old 8080 instructions, right? And then the skip patterns for realizing each of those instructions. So it's an 8-bit processor. It had 256 instructions. So I come down here and we see that's the end of all the instructions. And then we get into like the little sections that execute each of the different instructions with their, related skip patterns. So this was all we needed to emulate the program that was the arcade machine. Then we had on interrupt, we have a video interrupt that occurs like at every scan line. And then what we do is we do a set queue and a read long instruction, which will just suck a whole bunch of video memory into the cog so that we can then, without having to do more memory access, we can point the streamer to it and it sends it out. But also it allows this XByte thing, which is using the FIFO to run concurrently. So we get the video lines in chunks and then spit them out. Oh, we can just.
So shared your screen.
So the 8080 processor, it had some funny, we did for the emulator. Let's see here. There were some funny things like we had to emulate the buttons, right? Because that was through some kind of IO interface that was memory mapped. And so we had some special instructions that would then look at the thing that's doing the button computation. And so we do the sound. We actually would also play little recordings to make the various sounds of the video game. And then we would generate the video, read the buttons, and then emulate the 8080. So we got it so that one cog was doing everything for the whole cabinet. And then when that was working, let's see, let me get to the top here. We just started up. Let's see.
Just a notch this way so that you're not blocking.
Oh, sorry. Okay. At some point here we have, let's see, why isn't it letting me, did I get to the end of my program? Oh, I got to the end. Somewhere we do a whole bunch of cog inits, or we just start up cog 0, cog 1, 2, 3, 4, 5, 6, 7, and point them to like, their own private segment of memory, and also to the ROM image that was in the machine. And then it just becomes a Space Invaders game. And so, it's a total of 24 pins off the P2. And it actually run power and everything to all these 8 cabinets. And then Jim Bagley did some neat stuff, and also Graham Coley, where I guess they know the binaries of these old games well enough to modify the behavior. So they would have it so that you could actually communicate between cabinets and set up competitive games for like some tank game and other things. And it was a lot of fun to work on this, but the whole point was just to demonstrate that 3 pins, 1 cog, and some memory, and you can like emulate an old 1980s video game in its entirety, even not needing a separate power cable. Okay, so any questions? I'm going to play the video that shows the thing in action, and I also have it here. If anyone wants to come see it later, I'll have it set up. You can come play it. We don't have the nice cabinets because they're in customs, but we have the guts of everything that is demonstrable, and we have a TV over there that we can hook into it.
I have 2 questions. The first is, where do you get the binary for the game? Is the binary published somewhere?
It's on the interweb somewhere. I don't
So
know.
you get the binary for the game, and then where is the code that you execute on the P2?
Okay, I was showing that as we were going through. I was showing the emulator. I was showing actually the entire application, and part of it was the emulator program that had the bit patterns and the XByte stuff.
I meant, where can we get it?
Oh,
OX?
I don't know. I don't know if Jim put it up here or not. I'm sure he would, because it's nothing. It's not proprietary to us. It's just.
Yeah, so it would be kind of fun to download it binary and get it running.
Yeah, because you can replicate. I mean, you saw the schematic for the buttons. You could do this if you wanted to. But it is a bugaboo to make all the connections and everything to the cabinets. I'll show you here. Let's see. We want to go all the way full screen. Why is this not? Oh, wait. This window gets crowded with all this stuff. Let's see. Oh my goodness, this goes.
On the button, use a lookup table to determine what buttons are pressed.
I believe.
Non-linear ranges.
Yeah, I do. Okay, so for our thing that does the 5 buttons, 1 pin, yeah, it's a non-linear thing, and I could have probably successively added and compared, so add like double integrate and come up with a table, but I think I just had a lookup table that says, is it, you keep looking until you exceed. or it exceeds you, and then you're that one. Okay, now I'm trying to get this to take the full screen here. And then, oh wait, no, this, okay. Oh my goodness, all the stuff in there, I gotta keep shifting things around. Okay, no, this isn't it, hold on.
Consider using R2 on that one?
Well, what would it do? Oh, we could compare. Oh, I see what you're saying. You know, I thought about it for a while and I couldn't figure out how a single button press would resolve anything other than some nonlinear effect on the ADC reading. But you would know. I know you're good at doing things like that. So, but I couldn't figure it out. I just figured it was going to be nonlinear. We're using like a octave resistor value thing, and the ADC is more than enough to resolve that. We could have added a couple more buttons, I guess. Oh, so okay. When you first start up, the assumption is no buttons are pressed, right? So it's taking a measurement that it assumes no buttons are pressed. So that becomes the reference for further measurements. And it's doing something where it's actually modifying the number of loops in the ADC to kind of like fit, so it doesn't even have to do any math. It just kind of like does the number of iteration that gets you the number that you can then compare against the table. Hey, Ken? Okay, I think I like boogered up that window you had open. What do we do? Do I go to YouTube?
Yeah.
Are we out of time?
YouTube browser window open.
Well, I
was
don't-
actually on our home page is where I got it.
should we go to Parallax then?
Yeah.
Okay.
Meanwhile, there's a quick bite. If you Google 5 buttons on one pin, I wrote up Chip's code.
And I think it's on the OBEX too, right?
Yeah. And here's a nice picture of it, and the code's at the bottom. It's called 5 buttons on one pin. And then go to community, then news. News. And scroll to the very bottom. Going right there.
Okay, so
And there's a little video.
okay, so then we'll say watch on YouTube, make it big. Good luck. We're gonna need it. Wait a minute. Okay. Let's see, is this? I guess we're gonna have to suffer an ad for a few seconds. Okay, so let's see. That's that motherboard. There are the game cabinets. So Jim Bagley and Graham Cole designed these nice cabinets out of plywood, and they made these nice decals to go on them. And they've simplified the design. See, there it is. So there's the motherboard with 8 RJ45 cables coming out. Each cable goes to one. So that little board is powering every cabinet and then handling all activity over those 3 wires per cabinet. And because they're all running, they're completely stateful. They're all independent. One game could be ending, another could be starting because they've got all their own memory. We're just emulating 8 of them. Any other questions?
Very nice.
You know, it was one of these probably $15 Amazon things. I've got one right here. No, we were running, because the video was taking time, the emulation was taking time, reading the buttons was taking time. I think we ran the chip at 200 megahertz, and it seemed to be approximately about the normal game speed.
We got a R2 on it. I think you need to have both a high and
Yeah, you'd have to have like a single pole double throw, not a single pole single throw. Yeah, you'd have to switch between. Then you could get a nice linear output. Yeah. And we used like I think 1% or 2% resistors for that. We bought a bunch of these resistor packs and put them up. I don't know if they're still on our website. It's like pennies worth of resistors in the buttons. Did you leave that computer there?
I just am having trouble getting it out of playing the next YouTube video.
Just shut the browser.
Okay.